John Playfair, astronomer and mathematician in Edinburgh. He set up the Royal Society of Edinburgh. In the late 1700s, he came across the Surya Siddhanta, which contained tables of astronomy and trigonometry. One of the tables was a table of signs, and one of the other tables was a table of worst signs. Playfair writes, the Brahmins call the sign of an arch Kramajya or Jyapinda, and the worst sign is called Utkramajya. They also make use of the cosine or Bhujajya. All these terms are to be derived from the word Jya, which signifies the chord of an arc, from which the name of the radius or sign of 90 degrees, that is Trigya, is also taken. He remarks further that the use of signs was unknown to the Greeks, who calculated by help of the chords, which forms the striking difference between Indian trigonometry and Greek trigonometry. This book contains a very sober and rational system of astronomical calculation and even the principles and rules of trigonometry. Before Playfair talks about the trigonometry of the Brahmins, he finds it very important to talk about a peculiar geometrical principle followed by them. They express the radius of the circle in parts of the circumference and suppose it equal to 3,438 minutes or 60ths of a degree. In this, they are quite singular. Ptolemy and Greek mathematicians, after deriving the circumference, supposed the radius to be divided into 60 equal parts without seeking to ascertain in this division anything of the relation of the diameter to the circumference, like the Hindus did. This rule also makes it very clear that the Hindus were not borrowing their mathematics from the Greeks or the Arabic mathematicians. Let us talk about the basic property of the table of signs, which is to be found in the Surya Siddhanta. If there be 3 arches in arithmetical progression, the sign of the middle arch is to the sum of the signs of the 2 extreme arches, as the sign of the difference of the arches to the sign of twice that difference. There are some unique properties which the Hindu tables had, which allow us to guess their antiquity. He says, now it is worth remarking that this property of the table of signs, which has been so long known in the East, was unknown to the mathematics of Europe until the late 1500s. It is worth noting that the rule on whose basis Hindu trigonometry was founded escaped the notice of Ptolemy and numerous mathematicians who came after him, both European and Arabian. Although these later mathematicians made many discoveries, contributing many valuable things, the theorem on which Hindu trigonometry rests, which allows every number in their tables to be calculated from the previous 2 by an exceedingly simple process, was not to be rediscovered until it was Vieta who found it at the end of the 16th century. This theorem was then soon after applied to calculations and gave the trigonometrical canon a simplicity which of course was already known to the Hindus at least 3,900 years before the Christian era. This according to Playfair. In our next series of films, we will deal with how Playfair came to the conclusion that Hindu astronomy and trigonometry was exceedingly old. I leave you with the theorem on which Hindu trigonometry is based, which is, of course, very well known today. If there be 3 arches in arithmetical progression, the sine of the middle arch is to the sum of the sines of the 2 extreme arches, as the sine of the difference of the arches to the sine of twice that difference.